Okay, I'm just trying to figure out how to use this thing. Okay, I want to show you what what it would look like to be in my AI-assisted data analysis course. So what I'm looking at here, it's actually an HTML version of a Jupyter notebook, but this is a command that I basically sent to Python on my own computer. And I also gave this same file to the AI, which in this case was ChatGPT, and then I said, describe the contents of this file. So this is the request that I made of the computer, made of the AI relative to this file. And here's the response, which I got. And it told me an awful lot about the file. Fairly large mortality and population data set. And it tells me what columns are in the data set. And gives me a lot of good information about it. Each row represents essentially one population, 1 year, one age. Illustrates it for Australia. And then it gives me some information about missing values. And then I sent another prompt that said, list the countries with missing data. And I got back some information about which countries were missing, so I'll know not to mess around with Belgium, which I might have used. I thought it was a fairly normal country. And I'm not going to do anything with New Zealand subsets. And of course, I'm not going to touch either Russia or Ukraine for mortality analysis. Okay. So now comes what I call programming in English. And this is exactly what I sent to the AI. I want to plot the ratio of actual deaths for the 2015-2019 reference rates by age. And it said use males in the USA in the year 2020. The horizontal axis should have values 0 through 89, one for each age, and the graph should be interactive so that hovering over a point would display the age and the value of the ratio. And there should be a horizontal line at 1.0. And what I'm doing, I'm comparing a year, and I'm focused really initially on the period right after COVID started. So 2020 is when COVID began. And I took the mortality rates from 2015 through 2019, and I'm going to use the mean value of the mortality rates in that time period for comparison to see what the total impact of COVID was on our mortality rates. And this is what I fed in English, and this is what the large language model gave me back in Python. And this is I ran this code actually in my Jupyter notebook, and this is what I got. And I think it's a really very interesting picture. USA male death rates in 2020 relative to 2015, 2019. And here you see the dividing line at 1.0. So if nothing had happened to the mortality rate, you would have expected things to be right about here. And you can see which years for males, which ages for males were most affected. And this is very interesting that the greatest increase in the mortality rate for males in 2020 relative to that base period was actually at age 41. And it increased what is essentially the probability of death by about 30%. Also very interesting is that in 2020, the COVID experience appears to have actually had some sort of preventive effect for people under the age of about 10. You might wonder why this is, and my suspicion is that as a result of COVID, what we did during 2020 kept these young children out of circulation, maybe saved them from dying of automobile accidents. So again, this is an analysis of COVID, not from the perspective of hospital admissions or certificates of death or anything else. It's just what happened to the population. Some of this may be because people were not able to go to hospitals when they got very ill. There's lots of reasons why all of this could happen. So in order to prepare myself for doing all sorts of other things, following up with not just USA males for age for that particular year, I said, convert the code above to a Python function with 3 parameters: a country name, a year, and a gender. And this is so again, this is the programming in English. And here's the resulting Python code. And I tested it out for Canadian females in the year 2020. And again, there's some kind of interesting things in this graph. First, at the very young age, you see extremely erratic changes. And I assume that this is really just a result of large, rather small sample sizes. And the greatest increases were for females in Canada. The worst case was age 27 with a ratio of 1.431. Also interesting, what I find in looking at this graph is that after about the age of 50, things looks like there was basically no effect at all after age 50. Not higher, not lower, just hugging that reference line at 1. Okay? Then I took a slightly different tack. I wanted to look at the actual death rates over time for males at age 41 and make sure that what I was seeing in that ratio graph made sense. So here's the English, write Python code to produce a time series graph of male death rates at age 41 for the USA beginning in 1980. And again, make sure the graph incorporates hovering. And here's the Python code. And here we go. This is kind of an interesting graph. It shows that there was a period of declining death rates for age 41 from about 1995 to 2013. Clearly a distinct climb or distinct decline. And then between 2013 and 2018, well, this 2019, this is the period of time, the mean value of this period is what we're taking for the reference rate. And then 2020 happens and boom, you go up here. So yeah, what I was seeing at age 41 did make a lot of sense. And I thought, okay, well, I might like to do that for other countries, maybe other time periods, maybe different ages, and maybe different genders. So again, here's programming in English. And here's the Python code produced by the LLM as a result of the English code. And here I said, let's look at the death rate for Swedes. Swedish males, age 41, starting in 1980. And this is also an interesting graph. It shows a real steady decline from 1980 to about 2010, then it essentially flattens out. And what I find particularly about this, what I find interesting about this graph is that nothing really happened as a result of COVID, at least in Sweden. And then don't just ignore that. Okay, so that's what it looks like programming in English and doing data analysis. And you can see that with the great variety of data that is available here. Let's go back up and review what possibilities there are in this data set. Go back up to the top. There are 445,140 rows. So you've got data on 50 countries, and you've got single year of age data for females and males. I think you could probably come up with interesting questions to explore with this data for weeks and never stop enjoying yourself. Okay, so that is all I'm going to say. We can talk about this later.